Hello guys and welcome to your channel which is SciEngineers. This is Sushant. We have been uploading videos for your engineering entrance exam preparation and this is the topic of physics. In this video we are going to be discussing on the 11th standard topic which is forces. So if you're new to the channel you can just subscribe to our channel to never miss a notification from us. Hit the bell icon which is just beside the subscribe button. Also in the description below we have given the playlist for the Mhtcet mathematics section and the physics section, so you can just check it out. Also we have other playlist for your preparation for the first semester of engineering. So we have the subjects for your engineering mechanics, the basic electrical engineering, and also for your applied mathematics 1. These are the three main subjects which are considered to be toughest of all, and they are going to be of the maximum credit for your first semester of engineering. So in the current lockdown you can start preparing for them and just have a glimpse of what engineering subjects are going to be like. These three subjects are common to all. So let's get going with today's video. So in the first question, we have a block of 10 kg which is moving in the x direction and it is having an initially constant speed, but then it is subjected to a force which is of 0.1x. Now during this travel, which is going from 20 to 30, so the force is applied during the traveling from 20 to 30 meters. I need to find what is going to be the final kinetic energy. Now the concept which we are using over here is nothing but the work energy conservation or the work energy theorem. So for that I need to find what is the work which is going to be done by this particular force. So we know that the force, that is, let us say the work done dW, is going to be nothing but the force applied into the displacement which is carried out. Now since it is a retarding force, it's going to be a minus dF dx. So your dW or your W is nothing but going to be integration of f dx. So f is 0.1x dx. Now here we need to understand that the displacement which is going to be considered is from 20 to 30 because in that particular duration of traveling the force is applied. So it's 20 to 30. So if we calculate this particular integration, we'll be getting this as 0.1 x square by 2 with the limits of 20 to 30. Now coming to the work energy conservation, that is nothing but the work done will be equal to change in the kinetic energy. So the work done is minus 25 and the change in kinetic energy, that is the final kinetic energy minus the initial. So we need to find the final, so let us write it as K final minus the kinetic energy which is initial. So initially it was moving with 10 meter per second, so it's going to be half into m, that is 10 the mass, into v square, so that's 10 square. So this value comes out to be 500, so it's 500 going that side, so it's 25. So the value of kinetic energy is coming to us as 500 minus 25, which is nothing but 475. That's nothing but option. Moving to the next one, we need to find the torque which is going to be produced by this particular force acting in this direction and about the origin. So whenever it is about the origin, we need to just find the cross product of R cross F. So your torque is going to be nothing but R cross F bar. So we know the cross product can be solved with ijk, that is the determinant of ijk. And first we need to find the R values. We need to write the R component. So it's nothing but 1 minus 2 and 1, and the F values, that is minus 2, 2, 3. We cannot do it in the other way because then the answer will be wrong. So it is equal to the I component into the cross product. So into this is going to be minus 6 minus 2 minus j into this product, that is 3 plus 2, and plus k into, it's going to be 2 minus 4. So we are getting this as minus 8, this is minus 5, and this is minus 2. So it is minus 8 I cap, minus 5 j cap, and minus 2 k cap, which is nothing but your option In the next question, we have a 40 Newton block. So let's draw the block. So this is the 40 Newton block, which is supported by two ropes. One rope is in the horizontal direction and the other rope is at the angle of 30 degrees. So obviously, logically, the rope should be in this particular direction. So I need to find what is the tension in the rope attached to the ceiling. So I need to find this particular tension, that is T. So let us write this as T1 and this is nothing but T2. And this is my weight, which is 40 newtons. I need to find what is the tension in the attached rope with the ceiling, so I can directly take the component of it. And since the angle, now since the rope is making an angle to at 30 degrees with the ceiling, so that's nothing but it is making this angle as 30, so that means this angle is 30. Next, so finding the component, the y component of it. So the y component is T1 sine 30 will be equal to 40. So directly we'll be getting the T1 value as nothing but 80 newtons. In the next question, we have a body of 0.25 kg projected with a muzzle velocity of 100 meter per second from the tank of 100 kg. And what is the recoil velocity of the tank? So this concept is basically coming under the conservation of momentum. So the initial momentum should be equal to the final momentum. So let us consider that this is the tank, and from this we have a particle which is being projected. So this particle is going to go in this direction with 100 meter per second and its weight is 0.25. This is my tank. It's a very bad drawing, so tank we can just consider it. So it's of 100 kg and I need to find the velocity v. So obviously conservation of momentum, since this is going to go in the forward direction, this velocity will be going in the reverse direction. So momentum is conserved initially. When these two were together, the momentum of them we can consider it as 0. So that 0 will be equal to nothing but the momentum finally. So the final momentum is nothing but 100 into 0.25 minus 100 into v, because momentum is nothing but mass into velocity. This is equal to 0. So from this we get the v value. You can see that the 100 gets cancelled out. The velocity will be 0.25 meter per second. That's nothing but option. So in the next question, it is talking about finding the center of mass. So if you just read the question, you can see that there is a disk which is of radius r, and from that disk we have taken another disk, basically a disk part, a circular part from this bigger disk. The radius of the bigger disk is r and the diameter of the smaller disk is r. That means the radius of this disk will be r by 2. So I need to find what is going to be the new center of mass for this particular figure, wherein this particular small disk is removed from it. So we know that the center of mass is given by the summation of m, that is the mass, into the centers of those mass divided by the total mass. So that gives you nothing but the center of mass. So x is nothing but the centers of those mass from a reference point. So in this case, we'll be considering that O as the reference point, because everything which is given, that is the distance in the options, are given from the center. So it's r by 4 from the center, r by 3 from the center, and so on. So we're considering that the origin is the center, and from there we will be calculating what is going to be the center of mass. So this will be equal to, so let us say that it is nothing but x bar is equal to, now in this first thing which you need to observe is we need to just calculate the x bar, because y bar, because it is a symmetrical figure, there is not going to be any y component to it. We'll be just having the x component and the center will be lying on this particular line. So summation m into x. So for the entire figure, now since the density, we can consider that the density of the disk is uniform in nature and the thickness is also uniform. So we can, instead of considering masses, we can relate it with the areas. So we will be finding what is the area of the outer circle. So it's going to be nothing but pi r square, and the distance x. So since the bigger circle will have its center of mass at the center itself. The distance of x from the reference point is going to be 0. So this is into 0. Next, we'll be having the next term, which is of this thing. Now, since this particular mass is being removed, the value for the mass is going to be negative. So that is why it's going to be minus pi r square by 4, because the radius for the smaller one is r by 2 into the distance of that point. So we can see that the distance from here, it's nothing but r by 2 divided by, because its center is at this point, divided by the mass, the total mass. So total mass is nothing but the total area. So that's pi r square minus pi r square by 4. So from here we can see that the pi r square gets cancelled out. So pi r square gets cancelled out, and we are remaining with the numerator term is going to be r by 8 divided by the denominator term is 1 minus 1 by 4, which is nothing but 3 by 4. So 4 gets cancelled out with this. It becomes equal to r by 6. It's actually minus r by 6 because of the negative. So negative sign indicates that the center point is shifted from here in the left direction. So it's nothing but r by 6 from the center. That's nothing but your option. So as you guys know, for your practice purpose, we also provide you questions, and the solutions are being posted in the upcoming video. So these are the two questions for this particular video, wherein we have a square plate, which is the square plate of the dimension 20 centimeter, and it is having uniform thickness and density, and there is a circular part which is being removed from it, which is of diameter 8 centimeter. I need to find the center of mass of this entire thing. And in the next one, we have this particular system wherein the masses are given for M1 and M2, that is 1 and 1 by 3. I need to find M3 such that M3 is going to be at rest in this particular system. So these are the two questions, and the solution for them will be provided in the upcoming video. So thank you guys for watching our video. Do let us know in the comment section how do you find these videos, how it is helping you guys. Also, do like our videos, do share our videos, and do subscribe to our channel if you have not subscribed to us yet. Do hit the bell icon to never miss a notification from us of the regular updates of the videos or the contents which are coming. Those who are new to the channel, we would like to remind you guys of the playlist which is there for the Mhtcet preparation for the mathematics and also for your physics section. Also, we have different playlists for the first year of engineering subjects like Mathematics 1, Engineering Mechanics, and Basic Electrical Engineering. So you can start preparing for them now itself for your first semester of engineering. So keep liking more videos, keep sharing our videos, and do subscribe to our channel. So stay safe, keep learning, keep watching, and happy learning. Bye.